In the last few years, I have been involved so much with operations and automation of software delivery, all that stuff, that some people may call me a DevOps guy, even though I don't really like this title. I'm organizing from Riga myself, from Latvia, so I'm organizing a community there called Lightcraft, Latvian software cross-stream community, and I'm also organizing a conference there, which is called DevTernity. I'm also coaching, training, developing, consulting, all that stuff, do a lot of things, speaking as well. You can find me on Twitter, you can find me on the internet, it's not that hard. But I guess it's not that much interesting to you. The most interesting part here is what we're here. What is this talk about, I guess? It's the first talk, so let's talk about some fundamentals maybe. So this talk basically is a collection of patterns, and the collection of patterns and anti-patterns that I have seen during my work with different configuration management tools, with automation tools like Chef, Pub, Ansible, whatnot. And this collection that I'm going to present to you is not final. It's not final, it's really a work in progress, and it's just, you know, one of the ways to start to standardizing or starting conversations about how we should better write our configuration management. And of course, feedback is more than welcome. So if you know some other patterns, if you know, if you want to adjust the definitions on some of the patterns, please give the feedback by tweeting, by sending me email, or by publishing a blog post, whatever. This is very welcome. So let's first get from the most trustable source on the internet. We have Wikipedia, and this is a definition that you can find in Wikipedia for infrastructure as code. So infrastructure as code is the type of IT infrastructure that operations teams can automatically manage and provision through code than using a manual process. Infrastructure as code is sometimes referred to as programmable infrastructure. So basically what we have is code that expresses everything. The problem with handling that is that usually, or sometimes people forget that this is code. It's not just a tiny configuration file, it's code, and it should be treated as code. I will try to show you how. Usually the main players in the infrastructure as code tooling are, well, I split them in these areas. So the first one is the images, the base operating system image or the base container images that you use for your base infrastructure spinning up. This could be an image inside the cloud provider. It could be an ISO file that you use for spinning up your servers. It could be the base Docker image. And there are tools that lie in this area, and they help you out to create base images and maintain the base images. And there's some patterns also that apply to that. The next area is the declarative state of your infrastructure, and tools like Pub, Chef, and Ansible fit here very well. They're called declarations because we define what kind of state we want from our infrastructure. And all the rest that comes on top of that, something that has a probably different life cycle, like restarting servers or orchestrating servers, flushing the cache, deploying applications, all that stuff can go in this final area where we do more ad hoc maintenance and all that stuff. Okay, so image definitions, provisioning declarations, and automation scripts are the main infrastructure as code players. And there are tools that support each one of them. Just a few examples, like for image creation, you can use Packer, Docker, you can use, all the cloud providers usually have something for that. For state declarations, it's Pub, Chef, Ansible, Salt, whatnot. And for automation blocks, you can use different APIs. You can use SSH, you can use Bash, you can use whatever scripting that you like. It's not quite important. And as you can imagine, that list that I've shown in the previous slide is definitely not the complete one. There are many different tools. Now there's a nice picture that comes from a company called CBL Labs. And I think it's a bit outdated version because now they have an even bigger one. It shows all the possible tools in different categories that you can find for like deployment, logging, database, continuous integration, repository management. And there are many of them. But most of them have the same principles, they follow the same principles, they may have the same approach when you use them for the same types of tasks. Okay. But it all boils down to the fact that everything that we create with these tools, with our programming languages, with testing tools, is code. Everything is code. And the best place for the code is version control. That's where it should be. And the only way to get that code into the infrastructure is through automation. No other way. No manual stuff. Nothing should be done manually. Everything should come through automation processes. And this principle should be applied to all code. And it could be, just one click away. So you click the button, you can deploy your application or to production through staging, whatever it is. Or it could actually be just one commit away. So if someone commits the new change into the application code, usually, especially if you're going to the continuous delivery, continuous deployment mode, application will deploy it pretty much automatically. The same should go for infrastructure as code. So if anything happens on that level, it should probably be one commit away from deployment. Okay, let's see some patterns. Sorry. So I grouped them into logical categories that probably make sense, and I start with images. One of the anti-patterns that I know for a long time is called golden image. Have you guys heard of this? Golden image? No? Some of you? Yeah, basically golden image is a manually crafted base operating system image or base container image that was created manually, or there's no process of how it was created. And your whole infrastructure or big part of the infrastructure relies on creating it. Yes, do you have a question?
Yes, will your slides be available?
Absolutely. I will share them on Twitter. And actually, you can already find some of the previous versions of these slides on the internet, so yeah, no worries. This will be published. So yeah, the golden image is a bad pattern, because when you create your first server from that image, that's fine, but when you have to update your image, your old server stays with the old state, with old configuration, and you can't really version that, you can't really recreate that. So having golden image is a bad thing. And of course, the good pattern here is having reproducible image. You have to have a process to be able to reproduce your base infrastructure images, be it operating system image, be it image inside the cloud provider, or be it a Docker-based Docker image that you use for all the other images. And there are tools for that. You can use Docker for basically managing Docker images. You can use Packer as a tool for managing images for different virtualization software. You can probably even use ISO files if you know how to do them, which can also be one of the ways to put the foundation for your infrastructure in that sense. But this should be reproducible, because making changes to that and making new versions of that can be quite challenging if you don't do that. Okay, next group. Next group is called secrets. And even though I said everything is code, I would say that secret is not code. You have to think about security beforehand. And secret isolation is another partner that usually should be injected into any infrastructure as code. And basically, it's data that should not rely on version control, or should be at least encrypted in some way. Sorry. And that in ideal situation, the secret information, like passwords, private keys, whatever it is, should be injected in the very last stage of the deployment process, of the code deployment process, infrastructure code deployment process, and should only reside in different locations. This puts some constraints on how you design your infrastructure as code, how you use the tools, and most of those tools actually provide an ability to do this secret isolation. Of course, isolating is one thing, but also we probably have to encrypt them as well, and have to store them somewhere. And there are also tools that help you out with the encrypting stuff. So yeah, of course you can encrypt your hard drive, or the hardware with the secret sauce stores, but probably that's too much hassle. Also, you can actually keep encrypted files in the version control. Or you can use a vault service to actually get the secrets from another machine. So for encryption, in the version control, you can use things as simple as GPG, for example, and this is available on any operating system. Primarily on Linux, but also Windows is now kind of merging into the way Linux works, so it's also possible to do it on Linux. So you can encrypt your secrets and put them in the version control, which is probably not extremely useful and extremely easy to use, but at the same time, it basically gives a bit of flexibility and security. One thing I can definitely recommend, especially if you use Git, it's called transcript, which allows you to encrypt certain types of files inside the Git repository, and by adding a local hook into a Git repository, it will actually encrypt the files when you push them to the remote Git server, and we'll decrypt them back when you do checkout. So basically, for you as a user of the Git repository, the files will remain unencrypted, but remotely they will be stored in encrypted form, which is very handy and very nice to work. I use it quite a lot, actually. Also, you can use the different vault services or security storage services that are available. One of them, like generic one, is called Vault from HashiCorp, and each of the configuration management tools actually supports different types of encryption. So Chef has encrypted data banks, Puppet has higher GPG and higher YAML, and Ansible has Ansible Vault. And pretty much any of the other tools have an ability to encrypt stuff. So think about it when you design your infrastructure as code. And of course, if you don't do that, that could actually influence the way you work, the way the data nodes work between each other. For example, I have seen many situations. One thing, the operations guys have created a lot of Puppet code or Chef code, and they hard-coded secrets inside that. And for that particular reason, they never show the code to anyone from the dev team, because the rules, because the policies, because everything. But if you isolate the secrets, if you move them out, you can still share the code. So that's quite important, and don't fall in this anti-pattern. Isolate the secrets early enough. Okay, the next group of, probably the most interesting, is, at least to me, since I'm a developer, the next group of patterns is called code organization patterns. So the way you organize a configuration management code. And one anti-pattern that I see quite a lot, and that happens everywhere, is, well, I call it fancy file coding. Basically, you use the provisioning tool like Chef, Powder, or Ansible, or Salt, to copy all the configuration files that your software needs, or your all the packages that you depend upon need, and well, you know, there are actually much simpler ways to copy files. For example, let's imagine Nginx. Nginx is about HTTP proxy server, probably you know that, guys. And if you define that you copy the files that Nginx needs, and you copy all of them, then your configuration code will look basically like we copy these things, and we copy these things. And the thing is that, yes, there are much simpler ways to copy files, first of all. And another thing is that we're actually hiding abstractions. We're hiding what we had in our intent, because what we would probably like to do when we express our configuration as code, or infrastructure as code, is that we actually would like to define, we want to, let's say, configure an upstream server, we want to configure a virtual host, we want to configure a static directory, whatever it is. Tools like Puppet and Chef and Ansible, they actually allow us to do that. They have proper abstractions to help us out, to describe our intent better. And that's what comes with the clean code. As the developers usually know what's clean code, and the main teaching from clean code is that express your intent with code as much as possible. And when you just use files, copy them to the target machine, that's probably not the intent of your configuration. Your intent is this one. And in that sense, there's probably a pattern that tries to solve this. It's called infrastructure component DSL. And as I mentioned, tools like Puppet, Chef, and Ansible, they provide some building blocks to help you out, building those DSLs, like roles and defined resources and stuff like that. So, and you can write your own DSLs, or you can leverage existing modules that provide entry points to configure a reasonable engine. So instead of copying files, you define, I configure the upstream server, I configure the proxy server, I configure the downstream server, whatever it is. I define the exact components that I want to configure instead of just copying the files. That's how it roughly can look, for example, in Seder code, but of course it would definitely look in a different way if you use specific tools, but that's the same time. That's how you should try to write infrastructure as code, to make it as readable as possible for anyone who comes after you. And defining DSLs, domain-specific languages for your configuration components, or for your software, is not that hard, and you can use anything. Anything works. It's not that anything specific. You can use just scripting tools to do that, and the techniques are quite simple. Or you can use the existing tools like Chef, Puppet, and Ansible because they provide facility for that. Please learn all the things that this tool provides and try to extract the abstractions, extract the expression intent in a much better way. Another pattern is called incremental configuration. And the thing is that, similar with this Nginx example, when we copy all the files, usually when we get our packages from some artifact repository, they already have some default configuration state that is pretty much known. And instead of configuring everything inside that, we can only reconfigure that part that is needed. So we just do the incremental configuration on top of that. So we know that the package is it has some already the state that it needs to have, and then inside our provisioning code, we just define the particular value that we want to change, or particular restore that we want to configure, and just change that on the server. So this will make our provisioning code much simpler, because we will only express what we want to change, not everything that should be there. And there's some examples that you can use specifically for Nginx, for example. And again, the tooling that is available, the tools like Chef, Puppet, and Ansible, they already provide utilities for that. So Puppet is file logging OKS, allows you to inject some configuration to existing one without destroying or making exclusive ownership of the configuration. In Ansible, there's lining file and replace. In Chef, you basically have full Ruby to do that. And other tools also provide some abilities to do injection of configuration instead of making the ownership. Another way to organize configuration is called configuration composition, when we have to take control of the whole configuration, and then again we can use some existing abstractions that exist in those tools to make the configuration blocks express the better components. So imagine that our modules it's pretty much similar to DSL, but just usually the tools provided automatically. So we have the package with service component, and then it configures the server in the state. So the configuration, the final configuration file or whatever it is composed out of these blocks and put into the server by the module, by the tool. And examples here is that in Babel there's a concat module that allows you to concatenate several parts of complex configuration. In Ansible there's Ansible assemble module and Chef the partials. So please try to use them as well. Another pattern is actually that I've seen quite many times when people try to configure everything again with the help of provisioning tools, but at the same time, if instead they would use some existing packaging tools like RPMs or some zip files or whatever it is, and put the default state or default configuration inside that package, that would reduce the amount of provisioning code that you would need to configure that package. And of course, this is more like on development side, because developers are kind of lazy guys. They don't like to do extra work if they don't have to. And that's probably something that sometimes they actually should do, because if they deliver a package, ready-made package to the operations guys and let them write provisioning code around that, if that package would already contain the most of the configuration, then it will probably make everybody happier in the end. So instead of in your provisioning code, instead of saying that I want to put this file here, that file here, get this application code from here, I just put it on the package, and then in my provisioning code simplifies in that case. I just say get the package and install it. That's it. So simplify the code in a way. And of course, there are many different packaging formats, and jars, jams, Python code, TargetG, zips, RPM, DAPs, MSE, or we can even talk about server images and container images on that level. So it's just another packaging format that can be used to deliver applications and simplify the provisioning code that needs to be used to set that up. The next one is anti-pattern called data as code, and that's another anomaly that I see quite a lot in provisioning code. When you basically put a lot of things that look similar, like for example, if you manage all your 200 users using provisioning code. That's probably a bad sign, because those users probably should leave somewhere else, because every time you do add a new user or you remove the old user, you have to run your provisioning software on top of your servers to modify that. So maybe it's time to actually think that maybe we should put our users into LDAP. Maybe we should manage some our users in a different way, because this becomes data. This it has a different life cycle than your provisioning code. And you have to, sometimes it's fine. If you have like 5 or 10 users, it's fine to manage them with the provisioning tool. But at some point, it will become very painful because your provisioning code and your user database, they have different life cycles and have to be isolated. The same goes for the fact if you define the mapping for your server configuration for every of your for 500 servers, that also is a sign that something is wrong. Because again, this data can be put somewhere else. Or you can instead use different techniques, like apply server roles based on server name, for example, to your configuration. One way to fight this configuration data is code antipattern is using configuration discovery, and this usually basically means that we isolate some of our configuration data into a separate data source, and either our provisioning code or our application, it has an ability to discover that configuration on demand when it runs. So instead of putting everything into our provisioning code, we extract it and put it into the proper data source. And it may work like this. So we have a package, we define a package in our provisioning code, and when we run the provisioning of the server, part of the values actually are received from that discovery service that gives us those, or maybe even many of them. And there are many tools that are available at the moment, and I think every month we see something else appearing. So etcd, Eureka, Zookeeper, Castle can kind of help in this regard to isolate your data or from your configuration. And in that regard, you can also define another pattern called configuration data source, which could again be anything. It doesn't need to be specifically that server. So you can extract some of your data sets into a data file and store it in a database, or even use your infrastructure as a service API to be as a data source for your provisioning code. And in that regard, we can also define the infrastructure query pattern, which basically is an API that allows us to query our infrastructure. For example, the Amazon API has an ability to give everything you have inside your cloud provider, and you can use that information in order to feed it into the provisioning code. And this actually works very well with Ansible, for example, and this also allows you to make your provisioning code to be more dynamic rather than static when you have to map the provisioning code to every server that you have. Yeah, another pattern is environment template. And yeah, that's basically, usually you don't have one server in your environment. You probably have more than one server, and you probably have some other resources that compose your staging environment, production environment, development environment. And it's sometimes good to have script or tool or description that allows you to spin up the whole environment from that template. And there are many tools that can help out with that. For local environments, you can use Vagrant. For cloud environments, you can use AWS CloudFormation if it's AWS. If it's more cloud agnostic tool, you can use Terraform. You can also use Docker Compose to spin up the set of Docker containers. And Kubernetes API can be used to do kind of the same thing, but in the cluster of Docker thing. Okay, code organization. Any questions about code organization patterns? No. Yeah, you have.
Isn't there a conflict between the fancy file copying and the extra packaging? So you said, okay, clean code,
yeah.
Show the intent. When I do
but
extra packaging, nobody knows what I put in there.
Yeah, but the fancy file copying is basically when you express, you copy all the configuration files through the provisioning tool. When you define all these steps, the extra packaging code is like its isolation from your provisioning lifecycle and your release lifecycle. So the release part, releasing the package, with the default settings, with the default files that I needed for that particular software component, and it lives in the artifact repository. So inside the provisioning code with that, we don't have to specify anything. We just use the.
Yeah, but I couldn't share as I do before when I express my intent with Nginx Puppet module or something else. So it hides everything.
Yeah, it can hide everything. Yes. Well, but it's not well. It hides everything. The thing is that you don't have to use every pattern exclusively. Probably some of the patterns maybe are good for certain situations, other patterns are good for other situations. Because as a developer or operations guy, you can decide whether it's easier to put everything in my default package and whether the default state is enough to make the application run and then just make small injections of configuration when I need that, or you actually need to be expressive. For example, like with the Nginx module, you probably need to be expressive because that's what your application needs to have, a proxy to have. But for your own software packages, probably it's easier to have it as a package because you know what's inside, you know what's good for that, and yeah.
You were talking about using DSL to specify how I want my application to be configured.
Yeah.
Basically, that means I have some kind of file or configuration that expresses what I want my application to do, but in the end, the configuration files for the application have to be generated somehow.
Yeah.
That adds an extra layer of complexity.
Well, yes, but also
at what point do you think this is worth the effort? Because a lot of configuration files already use some kind of abstract way to define what I want.
Well, for standard software packages like Nginx, Apache, or MySQL, whatever, there are already a lot of modules that define these DSL components that you can use inside your configuration. So for these standard packages, I would use those injection points, configuration points, that are provided by already existing modules. For your application, maybe, I would try to minimize the number of abstractions, but still try to make it as clear as possible for anyone using the application. So of course, of course there's a limit. Of course, you shouldn't try to express everything. It's just, it's always common sense. Okay. Okay, the next set of patterns is set up around code quality, and the main anti-pattern to me is that people are not treating the infrastructure as code. They treat it as some random files, and basically because it's code, it has to be version control. It has to probably go through code reviews, and yes, there are static code analysis tools that you can run on top of. Ansible files, Puppet files, whatnot. Probably doesn't make a lot of sense to write unit testing, even though you can. You write unit tests against the Puppet or Chef and Ansible, but probably integration testing is more relevant here, and especially with all the cloud providers who have with all the virtualization, we can easily test that, and there are tools for that. And if we apply everything on top, we combine it all together, then this will probably give the best quality assurance for the infrastructure as code. So we need to treat infrastructure as code as code. It is code. It should follow the same guidelines. So for testing the state of the servers, state of the servers after the provisioning cycle, we can use these tools, server stack and BATS. BATS stands for Bash Automatic Testing System. It's very simple, but at the same time quite powerful because you can just test the state of the server after the provisioning. And provides you with nice reports. So not many people know those tools, but yeah, they do exist. In anti-patterns that often comes when you get people on team with development background, they don't follow the styling guidelines, and each of the tools that we mentioned and some others, they do have styling guidelines. Just find them. They are there. It's not that hard. Because eventually, for me as a developer, this is obvious, but it's not obvious for some of the guys from sysadmin background. Because if the code is stored in version control and we're following the same styling guidelines, then it's easier to merge, it's easier to read, it's easier to reason about the code. And again, there are many tools for that. For shell check, there's a bash or shell scripting tool for checking the styles of the shell script. For YAML, if we're talking about Ansible in general, YAML files, Puppet lint, Ansible lint, Food Critic for chef, and probably there are many more that help you out with that. So it's not that hard to put these tools into your infrastructure as code pipeline and check the code on every commit, and then send a report to someone who broke that. Okay, this is the last section. It's called side effects. I just didn't find any good category, but that's why I call it side effects. But also, I think some of the quite important patterns and anti-patterns. So this one is called metrics as code, and this is something that's often forgotten by developers to express what their applications are doing, what's important to monitor and to understand if the application is up and down or how it's performing, all this stuff. And usually it's the responsibility of operations guys to configure the metrics around the application. But the thing is that as soon as the application code evolves and architecture changes, probably the metrics also change. And in that sense, they probably should be also expressed as code, not just manually configured inside the monitoring tools, but actually stored together with the application code or with your infrastructure as code and evolve together with applications that have the same have a step somewhere in the pipeline, in the software delivery pipeline, where you deploy those metrics together with new application and new provisioning code. And to some extent also can be done in a discovery fashion. And most of the monitoring software actually provides APIs or a way to configure them with additional data collection and reports and dashboards, all this stuff. This can be expressed and stored together with the rest of the code. Yeah, there's some examples in Java that I can use, and actually there are many more than that. So it's possible to extract metrics, dashboards, and all that stuff and store it together with the rest of the code. Another one is called control panel as code, another pattern, which again is another important bit to me. Most likely, you're already using some sort of continuous integration server or some automation server, which is the source of your, in which you press the button and deploy code, or which automatically does the deployment when someone commits the code, and does this pipeline, all the automation jobs that are put into that control panel, which could be Jenkins, which could be Rundeck, could be TeamCity, whatever it is. I have seen many cases when the configuration of that CI server or control panel, as I call it, is not stored anywhere. So it's just there inside the most important server, and nobody backs it up. But the thing is that, again, there are ways to extract that, the definition of your pipeline, the configuration of your jobs into code, and store it together with the rest of the code, as I mentioned. So configuration should also be kept in version control. And if we talk about Jenkins, how many of you guys use Jenkins? Yeah, pretty much everybody. Well, almost like 78%. So Jenkins has an API to extract, to control the job configuration. So you can use that API to populate Jenkins with the jobs. Job configurations on demand. There's also a job DSL plugin that can be used to express in a nice groovy DSL. And for Java guys, it's a Gradle plugin that can do the same using the Gradle build tool. And I mean, it's just a few options. There are many others. It's also now Jenkins 2.0 introduced the pipeline plugin, where you can extract the whole pipeline as code as well and store in version control. So think about it when you configure Jenkins. The whole configuration of Jenkins should be either provisioned with the provisioning tools, and each provisioning tool actually has, Ansible has plugin for Jenkins, Puppet has plugin for Jenkins, Chef has plugin for Jenkins, so it's, and probably for some other CI tools. So it's important to keep that part in the code and make it maintainable, because yeah, eventually this will become the most important server in your whole infrastructure, because it's responsible for deploying your code into production or to staging environments and all that stuff. There's another control panel-like tool called Rundeck that I also use sometimes. It also has an API, it also has a command line. So tooling is there. Just make use of that. Yeah, another anti-pattern that I can mention here. I mean, it's not as important, but I've seen that already happening a couple of times. Is that there are many modules available for Puppet, Chef, and Ansible, and what usually, and some of them are of different quality. Some of them are good quality, some of them bad quality. And what I've seen happening is that people take the module as is and put it into their code, and it leaves there. So they basically make a fork locally, and they never submit things back, and of course they never get changes from the module as it develops. So in my opinion, one of the best features of these tools like Puppet, Chef, and Ansible and some others is that it has a great community, and it has, and a lot of things are possible because there are many modules available. And it's actually a responsibility of the people who use those tools to actually commit back, share back stuff, and have an ability to, to give the community something back. And to identify these kind of things, you can use the community module wrapper. So instead of taking the code and using it exclusively, you can just call the code and do some adjustments on top of that code, and have an ability to first of all upgrade the version of the module inside your code base, but also an ability to share something back if you do some possibilities. Okay, final two patterns, or actual anti-patterns. This was happening in real life, and this usually indicates that there's some mismatch between some parts of the teams, and I call it other stuff. So imagine you have a nice folder structure like this. So where you have, well, as your team knows what goes where. You have some scripts, procedures, some configuration, and you have some definitions, whatever it is. And then a new guy comes to your team, or a new team joins your organization, and they need to support additional stuff. So imagine what they structured. They have finally found the courage to actually commit something to your code base, and what they did. They just added a directory called other stuff. Which, yeah, doesn't make sense because it's apart from all the other tools that have been already in place. And it also indicates that basically the team, even though it commits the code, it kind of follows the guidelines, but at the same time, it doesn't really understand what is going on. So it indicates usually, this random structure in the code base indicates that something is wrong in the team, and you have to address it somewhere else. Something. And of course, the last anti-pattern, it's quite easy to create mass of out of anything, including infrastructure as code. So big ball of mud, this is anti-pattern that is known pretty much to every developer, is applicable to any code, including infrastructure as code. Okay, the last one, I forgot about that. This one is very important. This one is very, very important. I usually favor automation scripts, or the provisioning code, over documentation. I have seen so many dead documents, I have seen so many dead wikis, that I don't trust them anymore. I trust the code. And especially if the code is part of the pipeline and it is executed every day on every commit, then that code is much more trustable. That code expresses much more information about your actual system than any document that you can create. So automation over documentation is an extremely important thing. Okay, conclusion. So patterns are everywhere, and probably you've seen other patterns, and I've showed just some of them that I've seen. And patterns is a way to understand the big picture, but it may not always be applicable to every situation. And some patterns can be applicable in one situation, and some patterns can be applicable in another situation. But one reason why it's important to talk about patterns in general is because it places a common language into the community, and I hope this presentation starts it. And the list obviously is not complete. And feedback is more than welcome. So if you have some other stuff, please, we can discuss it later in the breaks, or you can just make a tweet or send me an email, whatever it is. Yes. And for the reference, I have this all patterns listed here, and this is it. Thank you.
We still have 5 minutes for questions.
Yeah. Just shoot. Any questions? What What was the best pattern that you've seen? Or maybe you know some other patterns. Yes.
Yeah, I would probably add something I heard from Shlomo Shapiro. He said clean as you go. So if you find something in the infrastructure code somewhere else and you say it's not right yet, sometimes you write a note and I will fix it. Sometimes fix it now if it's
but
if it's worth. So
if you know the clean code book from Michael Bob, basically it has a similar rule called voice code rule, which means that you have to leave the campground when you found it. So yeah, I think it's the general rule of any IT professional that.
Yeah, but in normal day life it doesn't happen often because I don't have the time now. I write it down anywhere, and sometimes I will do it, and you will do it never.
Put it on the backyard and just keep
Well, you have to plan for it. If you know that this code needs improvement and you don't have time right now, you have to make probably your manager aware of that we have some improvements to be done. We have to do them in any case and if you don't keep track of that, if you leave here and there and there and there, then eventually you will end up with a messy code. So you have to. Well, this is technical debt basically that you create. And if you don't pay your interest on the debt grows. So at some point you have to pay this interest and you have to reduce the debt. And